Dear students, in today's class, I am going to share with you the properties of determinant. This is the second class of determinants. If you don't have any idea about the determinants, then watch the first part of this video. Link of the first part of determinant has been given in the description box. There are 10 properties of determinants. Out of these properties, 5 properties are very important and useful. If you go through the whole video, I am quite sure you will be able to understand the properties. These properties are important because in order to solve the determinants problem, you should know the property. Property 1 says the value of a determinant remains unaltered if the rows and columns interchanged. What does it mean? Let me give an example for that. Let determinant, sometimes expressed by delta, that's why I have written like this, 1 minus 4 3 4 1 minus 2 minus 3 2 1. I am expanding this determinant with respect to first row, expanding R1, that is with respect to first row. You already know how to expand the determinant. So 1, remaining part 1 minus 2, 2 1 minus of 4, suppress minus 4, 3 2 1. Next minus 3 minus 4 3 1 minus 2 1 plus 4 minus 4 into minus 4 minus 6 minus 3 into 8 minus 3 5 minus 4 into minus 10 minus 3 into 5 plus 40 minus 15, so we get 30. The actual determinant is 1 minus 4 3 4 1 minus 2 and minus 3 2 1. Now if I interchange the rows into columns and columns into rows, what will happen? Determinant, by changing its rows into columns and columns into rows, we get another determinant and we call it delta 1. Now 1 4 minus 3, that is first row changed into first column, second row will be changed into second column, and third row will be changed into third column. Let us find the value, means let us expand this determinant. Expanding R1, 1, now 1, 2, minus 2, 1, minus of minus 4, this row suppress, this column suppress, 4 minus 3 minus 2, 1, next 3, this row suppress, 4 minus 3, 1, 2, 1 plus 4 plus 4, 4 minus 6 plus 3, 8 plus 3, 5 minus 8 plus 33 results in 30. What actually I wanted to show? Watch carefully. The actual determinant is like this, and interchanging it rows into columns, we get another determinant called delta 1, and expanding delta we already got 30, and expanding delta 1 we also got 30. Therefore we can say delta equal to delta 1, that is, the value of a determinant remains unaltered if the rows and columns are interchanged. I think you understood this property. Now try to memorize this property. The second property of determinant: if two adjacent rows or columns of a determinant are interchanged, the numerical value of determinant remains same, but the sign of the determinant is changed. What does it mean? In order to understand this second property, if I write the example from the previous sum, delta equal to 1 minus 4, 3, 4, 1, minus 2, minus 3, 2, 1. You can remember, by expanding this determinant we got 30. So the value of the determinant is 30. Let us interchange the two columns. So 4, 1, minus 2, and 1, minus 4, 3. Interchanging this column I have written here, and interchanging this column I have written here, and this column is in the same position. So the new determinant form is like this. If I expand this determinant, what is happen? Let's see what is the value of this determinant. 4 minus 4, 3, 2, 1, minus 1 into 1 minus 2 to 1 minus 3 into 1 minus 2 minus 4 3. Now 4 into minus 1 minus 6 minus 1 1 plus 4 minus 3 3 minus 8 4 into minus 10 minus 1 into 5 minus 3 into minus 5 minus 40 minus 5 plus 15 results in minus 30. So the value of the actual determinant is 30, and by interchanging two columns, interchanging two adjacent columns, we get the value of the determinant minus 30. If we interchange the rows, that means if we write another determinant like this, minus 4 1 2 1 4 minus 3 and 3 minus 2 1, and if we expand this determinant we also get minus 30. So the value of the original determinant is 30, and value by interchanging two columns we got minus 30, and interchanging any two adjacent row we also got minus 30. So we can say if two adjacent rows or columns of a determinant are interchanged, the numerical value remains the same because both are 30, but there is a negative sign, but the sign of the determinant is changed. This is very useful property. I think you understood this property very well. Now memorize this property for solving the problems. You are watching on the screen the third property of determinant, which is also very important and useful property. If two rows or columns of a determinant are identical, the value of the determinant is 0. What does it mean? A1, A2, A3, B1, B2, B3 and B1, B2, B3. Watch carefully. The second two columns are identical, means they are the same. In that case, if we expand this determinant, we will get 0. Write a determinant, say 2, 3, minus 1, 2, 3, minus 1, 5, 6, 9, and expand it. What you will get? You will get 0. It is not only in case of the columns. If two rows of a determinant be identical, then also the value will be 0. Say A1, B1, C1, A1, B1, C1, A2, B2, C2. Now look, the first row and second row of this determinant is identical, means they have exactly same elements. If you expand this determinant, you will get 0. If you try with this determinant 3, 5, 6, 3, 5, 6, 9, 10, 16, say, and if you expand this determinant, you will get 0. So this property says if two rows or columns of a determinant are identical, the value of the determinant is 0. You can use this property directly when in a sum you will see two rows or two columns like this, identical or similar, then you can write 0, and you have to write within the bracket using property. That's it. This is the fourth and very useful property of determinant. If all the elements of any row or column are multiplied by the same constant, then the original determinant is multiplied by that constant. What does it mean? I am not give you the proof because then the video will be very long. Let me make you understand what does the property say. Let A1, A2, A3, B1, B2, B3, C1, C2, C3 is a matrix. And if you want to multiply this matrix by a constant term, you can do it like this: 1 by k into k_a1, k_a2, k_b1, k_c1, k_a2, k_b2, k_c2, k_a3, k_b3, k_c3. We multiplied all the elements of this matrix by k, and so in order to balance up, I just take 1 by k outside. But remember, in case of determinant, if you want to balance up it, you just write 1 by k. You can multiply only one row or column, that is k_a1, k_b1, k_c1, a2, a3, b2, b3, c2, c3. That is, if all the elements of any rows or column are multiplied by the same constant, then the original determinant is multiplied by the constant. We just multiply only a single row by the constant and we put 1 by k outside in order to balance up. You can do the same thing 1 by k by multiplying by the constant in some column k_a1, k_a2, k_a3, b1, b2, b3, c1, c2, c3. You can do like this also. I think you understood what the property mean to say. So in case of matrix you can multiply all the elements, but in case of determinant you can multiply any one of the rows or columns, then the determinant will be multiplied by the constant. I think you properly understood the property 4. Now we'll go through the property number 5. The fifth property of determinant on the screen. If to each element of any row or column of a determinant, the multiples of corresponding elements of other row are added, then the value of the determinant remains same. Suppose A1, A2, A3, B1, B2, B3, C1, C2, C3 is a determinant. If we expand this determinant, we will get a certain value. Let the certain value be x. Now we are doing some determinant operation. We just write A1 plus k into B1, A2 plus k into B2, A3 plus k into B3. So we changed the first column only, and second and third column remains unaltered. Say B1, B2, B3, C1, C2, C3. This kind of operation we write like this: C1 prime. What does it mean? C1 prime means new. This is C1 and this is C1 prime, means new C1. Change to how we get it. We get it C1 plus k into C2. So we write this operation like this: C1 prime, C1 plus k into C2. I said if you expand this determinant and its numeric value is x, and if you expand this determinant you will also get x. We can write this in another form. We done here the column operation. We can do the same thing by row operation, like A1 plus k into A2, B1 plus k into B2, C1 plus k into C2, and the other two rows of the determinant unaltered: A2, B2, C2, A3, B3, C3. In that case, we write R1 prime, that is new R1, change by original R1 plus k into R2. If we expand this determinant, we also get x. So these are the 5 important properties of determinant that will be frequently used in case of solving the problems. So try to memorize all the properties repeatedly. In the next video, I will not discuss anything, but I will solve few problems based on these 5 properties. So don't miss the next video, but before that, make sure you can memorize all the 5 properties. No more today. I wish you all the best.